from the inside curve, how it comes over here. I'll show you in paint what is inside curve. So this is my curve. Okay. If I will put a mast over this side of the curve, it is called as an outside of the curve, because you can make a circle over here. So mast will be outside. But if I will put a mast over this side, it will become as an inside of the curve. Okay. Any doubt?
Yeah. Who will choose where I supposed to put the mast, inside or outside?
That's on the designer's point of view. It's given you the free hand. You can put either here or there, but consistency should be there. Okay. Sometimes it's not possible to put here because of due to some terrain or something other reason. You need to shift your master. You can do that, but always maintain the consistency. If it is not possible, you can change your side. Either side, I'm telling you. Either you might be putting this side, the consistency will be for this side, and you need to change it to the another side. It's totally depends upon you. If there is some geographical condition is not favorable for you, if it is costing you more, you can change the side. And if that is the curve, then this has to be followed: inside curve and outside curve. Okay.
Okay.
Sir, at the initial stage when the civil surveyor give us the alignment of the track, that time they write the radius and gradient at the down line, like whatever is the alignment, they show it below. So from that, like how does the like inside curve and outside curve, how will we point out that?
That's what I told you. Na? It depends on you which side you want to put the mast. On that, it will depend. So that's what I'm telling. Like the surveyor will give you the radius. Okay. He will tell like which side the track is moving.
Okay.
Okay. So he will mark it in this way. If this is this way downside, then it's going this side. And if it is going upside, if it is versine is marked like this, it will go upside.
Okay.
So this is the marking he will do over there. Okay.
Okay.
Is your doubt clear?
Yes.
Okay. And if any doubt anywhere, you can just go and ask your surveyor. Okay, you should always have your project surveyor's contact detail handy. Okay, so sometimes what he might be explaining on the paper, you might not be getting it. It's totally a human tendency. Okay, it's no one's fault over here. So instead of going and assuming something wrong, it's better to give a call and ask him. Okay, I always keep my surveyor's information with me in my projects, whatever I have done till now. Okay. So this is the wind pressure zones. Nowadays, it's like the wind pressure is divided into green zone, yellow zone, and red zone. Okay. So this has to be always kept into mind that if it is 75 to 112.50, it's green zone. And above that, it's yellow zone, but above 150, it will be a red zone. Like heavy wind pressure zone will be there. There, the span, the maximum span will reduce. Okay. Here, the maximum span will be 72, but here, the maximum span will reduce.
And the foundation for the mast, it's gonna be heavier or
heavier.
Matter?
Okay. Yeah, it will be a heavier, still more heavy.
Okay.
This is tension length. Okay. So I discussed this like we are always going for regulated equipments. Okay. We are always going for regulated equipments. We never go for unregulated equipments. Unregulated equipments means what? There will be no ATD, auto tensioning devices. Right? So we always go for regulated equipment which has a maximum tension length of 1500 meters. So this is called as an anti-creep center. Okay, so what it does, anti-creep centers. So this will be approximately at the center of the tension length. Okay. So what do you understand by this one? At the center of the tension length. What is my tension length? My one tension length is called as 1500 meters. Okay. What will be at the center of the tension length? Means how much meter it will be?
750.
750. See, on practical basis, we just cannot put this on 750. Some 50 meters plus and minus can happen. Approximately, I'm telling, at the center of the tension length. The work of this is that it's like we have two this balance weight anchor on either side of this tension length. Okay, so this is when we'll be starting. Imagine that this is the starting of the tension length. Here we will put the BWA. Okay, balance weight anchor, balance weight. And at the ending also we will put it if it is 1500 meters. Okay. So this will be at the 750 meters. So what it does is like the action of the balance weight will have an effect only till this point of the one balance weight. The another balance weight effect will only be till here. Only will be till here, this point. Are you getting my point, Ashwini?
Yes, sir.
Why we use anti-creep center?
To maintain the distance between, like to maintain the sag basically.
Sag between the one of the BWA and another of the BWA. The one BWA will have an effect only till this point. Okay, that will be the halfway. And the another BWA will have the effect only the halfway. Okay. Are you getting, Bilal?
Yeah.
That's great. So this is what this all will be like galvanized, okay? Because no rusting is allowed in this area. Everything will be galvanized. It depends upon the coastal region. In the coastal region, the galvanized, I just forgot how much the galvanized they will do it. It's like some is there, that measurement is there. For coastal area, it is different, and for the inner area, it is different. Okay. So that galvanizing test will also be done. We don't have to do it, but just for a general knowledge purpose, and everything will be galvanized. All rust proof. So this is how the anti-creep will look like. This is an anti-creep wire, how it is holding over here. Let's see. Give me a second. Okay. So here also it is shown like 750 meter or 15 supporting structure, anything it can be, okay, half tension. So this is how the anchoring of the mast take place. Okay. So how you do it? If it is total 1500 meter tension, then we need to have this balance weight on both the sides. But if the tension length is less than 750 meters, then one side we can have this, and the another side at the ending we can have this fixed termination. Okay.
Without
Any doubt
adding
in this?
any weight.
Yeah.
That is like
Any
half
doubt?
ATD and full ATD like that. No?
Yeah. You can say it in that way also. Okay. this is like a buffer end, where this buffer end will be like CST, VT, CST station or Churchgate station has having a buffer end, right? This buffering. So this buffering will be like 6 meter minimum. The anchoring of the wire should take place. But in some station like in Bombay, you know, Ashwini, like Churchgate or the CST, they don't have space behind. So what they do, they will have this type of things, or else they will have one more. They will have a pole over here and one more, and then they will end the wire. Okay. So you can see that whenever you go there and how they buffer it, because their 6 meter will not get. So they will just put a pole and they will put for this anchoring, they won't get the space. So they will go for this without
Yeah,
guy rod.
without guy rod.
Yeah. So this is how the ATD works. It's like auto tensioning device, a device for maintaining the tension of the OHE conductor constant under all ambient temperature condition. Okay, when the temperature will increase or reduce, this